Hi, grade 6. This is your math lesson for page 116, 117, 118, and 119. So this is your lesson for basically 2 days of work. Now, when we talk about symmetry, they've sort of divided symmetry into 2 different topics. The first topic, when we talk about symmetry, is if a shape has a line of symmetry. Basically, that means, can you fold the figure exactly in half where it will match up? So you can see in the gray box here, this rectangle has a line of symmetry because if I folded it on this line, it would match up exactly. Here, if this line here, if I folded it along this line, it would not match up. So it's not a line of symmetry. So basically, this shape does have symmetry, but they have the wrong line. So to find lines of symmetry, we need to ask ourselves, can I fold my shape in half exactly? And you can go from any direction. So you can do lines of symmetry straight vertically, you can do lines of symmetry horizontally, you can do lines of symmetry diagonally. So when we're looking at symmetry, we're looking at our shapes and we're asking ourselves, can I fold this exactly in half? And some shapes have multiple lines of symmetry. For example, a rectangle, I can fold exactly in half one way, like this, and I can fold exactly in half the other way, like this. Therefore, you can see my rectangle has 2 lines of symmetry, horizontally and vertically. Same thing with a, so this is a diamond. I have exactly 1 line of symmetry because I can only fold it in half once. And that would be 1 line of symmetry. There's no other way that I can fold it. Here we go. This is a trapezoid. And we need to see if this has a line of symmetry. I'm going to try fold it exactly in half. And I can do 1 line of symmetry, and that's it. Here is a parallelogram. And when I see a parallelogram like this, there is no lines of symmetry in a parallelogram. There's no way that I could fold this shape so that it would match up. There's always going to be, even if I tried diagonally, it just doesn't work. So there are no lines of symmetry in a parallelogram. So a shape can have no lines of symmetry, a shape can have 1 line of symmetry, a shape can have 2 lines of symmetry, or it can have many. So what you need to do is look at the, first of all, lines of symmetry they've drawn and say whether they are right or wrong. Then you need to look at shapes and draw your own lines of symmetry. When you draw your line of symmetry, grade 6, you need to use a ruler, and you should draw it how it's drawn in the book. So you must use a ruler, and you should use a dotted line. So please do that. Here you need to draw again, and you need to put the letter of shapes in the chart here. You have a couple more questions about lines of symmetry. You need to answer some questions about this pentagon, so not a quadrilateral, but a shape with 5 sides. You need to measure the sides first, then see if there's a line of symmetry. For here, you have to draw shapes. Please draw using a ruler. You need to do a shape without any lines of symmetry and a triangle with only 1 line of symmetry. here we get to our second topic. So that was about line symmetry. The second topic for symmetry is called rotational symmetry. Basically, this means when I turn my shape, so if I'm turning my shape all the way around 360 degrees, how many times will it go exactly back on itself? So I hope you watched that YouTube video that I linked to, because I find when we are talking about rotational symmetry, it's helpful to have more than just one explanation. When we think about rotational symmetry, it's a very visual topic, and so sometimes it can be hard to imagine depending on what shape we're talking about. But so for this one, we have 3 different shapes here, and each of these shapes is different. We basically have to think of our shape, and we have to think of it turning 360 degrees, and we have to pay attention to what's happening when we turn our shape 360 degrees. So if we turn our shape once, quarter turn, it looks the same. Half turn, it looks the same. And then a full turn back, it looks the same. So this shape has gone back on itself 3 times. That means it has an order of 3. So with rotational symmetry, each different shape has an order. So that basically means how many times does it fit exactly back on itself. This fits 3 times on itself, so it has an order of 3. This guy, if we turn him all the way around, so let's just start turning, he fits on himself once for a half turn, and twice. So that has an order of 2. This heart, if we turn it, basically it never fits on itself until we go back to the start position. That means it doesn't have rotational symmetry. Shapes that do not have that rotational symmetry, that never fit back on himself unless you go back to the start position, that means they have an order of 1. This one was order of 2. This one had order of 3. So the order of rotational symmetry is the number of times the shape fits back onto itself. So if we looked at this shape, we turned it and it could fit back on itself 3 times. The book does draw a dot on one corner, and that can help. So on this page, so this is page 118, you need to imagine turning your shape. So I would start by drawing a dot, turn your shape. So either you have to imagine it in your head, how many times would it fit back onto itself? If you find that it's hard to visualize, you can always cut out a shape in a piece of paper. It's very quick, and you can use that to help you. So, but I would start by labeling one corner and then think about that corner turning. How many times would it fit back onto itself? And write the number down. So for A, if we did this together and we turned this triangle, I sort of have a triangle already here cut out, but that one's equilateral. So if we think about my triangle, that's my dot, how many times will it fit back on itself? So once, so we start here, and we go 1, 2, 3. I have an order of 3. If I had a pentagon, how many times would it fit back on itself? You can imagine yourself turning the shape once for this to be the top, 2 for this to be the top, 3, 4, and 5. So I have 5. For here, you have to think how many times, so like let's say this is our dot that we're following. So imagine turning your rectangle. How many times would it fit back onto this position? So we're turning it all the way around. Once and twice. So try your best with these. If it helps, cut out a piece of paper and turn it. Then you need to, once you're done writing down how many times they fit onto themselves, or that's called the order of rotational symmetry, then you can divide up your shapes into the chart. So either they have 1 line, 2 lines, 3 lines, or 4, or more than 4. Remember that if they never fit back onto themselves except for at the end, that's 1. So that's the default. So G, for example, it would never fit back on itself, so it would be 1. For the last page, you have to work with both lines of symmetry and rotational symmetry. So first, you're drawing lines of symmetry using your ruler, and there is more than one in each of these shapes. Then what you have to do is write the order of symmetry below the shape, so how many lines of symmetry there were. Then you need to figure out the rotational symmetry. So once you're done drawing the lines of symmetry, then you have to do the part where you draw 1 dot, you turn it around, how many times will it fit back on itself, and write that down there. So for M, we would have a line of symmetry here, we would have a line of symmetry here, we would have a line of symmetry here, and that is it. So it'd be 3 lines of symmetry. And then when we turn it, it would be order of 3. And the number of sides, it would have 3 sides. So you need to do that for each of these shapes. Fill in the chart. And then you're going to predict. So this is triangle, square, pentagon, 6-sided. Why am I forgetting what that is? And then you're going to predict for this octagon. So this chart, once you have the answers, it'll help you with that. Last one here, you have to draw a 4-sided shape that has 1 line of symmetry, no rotational symmetry. So remember, that's only an order of 1. So it would only fit back on itself 1 time. Then you have to draw a quadrilateral that has 2 lines of symmetry and a quadrilateral that has 4 lines of symmetry. If you are having trouble thinking of something to do, just look back up here for what shape had how many lines of symmetry.